dimensional analysis method is a method that helps us in science and in mathematics when we need to work within different units than either the way it's presented or the way we need to finally give our result. This video is going to give you a few examples of the dimensional analysis method and hopefully give you a foundation to let you take that on to other applications that you might come across. So with the dimensional analysis method, one of the things that we need to always remember with this is that property that when we're looking at the identity property for numbers, that if you take a value and you multiply it by 1, you don't change the value that you originally started with. So 7 times 1 is 7, 12 times 1 is 12, each of those sorts of things. Now also, 1 can be written in a lot of different ways. In fact, when we look at different ways of writing 1, as long as our numerator and our denominator are exactly the same, and our denominator is not 0, that value is 1. So if I have 5 pi over 5 pi, 5 pi divided by 5 pi is 1. So when I look at that, that is like a unit conversion factor. Now, sometimes the numerator and the denominator are the exact same, but they don't look exactly the same. Remember with that is that still, if the numerator and the denominator are the same and my denominator is not 0, it still has the value of 1. So just like 12 divided by 12 is 1, 1 foot divided by 12 inches is 1, because 1 foot is exactly the same as 12 inches. If I write the conversion later on in trigonometry, that pi radians divided by 180 degrees, that's still just 1 because the numerator and the denominator are the same. Now when we're setting these up to help us convert between units, we want to take our originating value that we want to convert to a different unit and then think about what unit conversion factor we want to multiply by so that we take away the units that we don't want and bring in the units that we do want. I've listed a few equivalencies over to the side here so we can use that as a reference. So 1 foot is the same as 12 inches. 1 yard is equal to 3 feet. 1 mile is equal to 5,280 feet. 1 inch is equal to 2.54 centimeters. 1 kilometer is equal to 1,000 meters. 1 meter is equal to 100 centimeters. 1 centimeter is equal to 10 millimeters. 1 liter is equal to 1,000 milliliters. 1 pound is equal to 16 ounces. And 1 kilogram is equal to about 2.2 pounds. Now when I'm looking at what they're asking me to do over here, I see what I originally start with, and I want to write that, if it's not a fraction, we want to write that as that measurement over 1. And now I want to multiply it by the unit conversion factor. Remember, I'm multiplying by 1, so I'm not changing the value of the quantity, I'm just changing the units that it's being expressed in. Now notice that when I multiply this by my unit conversion factor, my numerator and denominator have to be equivalent to each other. They have to be equal so that the net result is the value 1. Also, I want to take away the inches. I want to get the inches units out of the expression and bring in what they request me to change it to, feet. So since the inches is the units right now and it's in the numerator of the fraction, to get it to divide out, I want to put inches in the denominator. And then I want to put feet in the numerator. So I figure out which way they go in the multiplication of the unit conversion factor by which ones I want to remove as common units and then which ones I want to bring in. Now I need to make sure this is equivalent to 1. When you're comfortable with the units, you think, well, which one is bigger, a foot or an inch? Well, a foot is bigger. So I'm going to give the foot the number 1 and then say how many of those little units make up that big unit. So are there 12 inches in 1 foot? So notice I have 1 foot and 12 inches. They're equal to each other So this is just a number divided by itself, and I don't have a denominator of 0. So that is a value of 1 multiplied, so I'm not changing what I have. Now the common units of inches from the denominator and the numerator will cancel. And then when I multiply across the top and multiply across the bottom, that gives me 72 over 12 feet. Divide that out, you get 6 feet. Okay, let's try the next one. 432 centimeters to meters. So I have 432 centimeters, divide by 1, times, I want the centimeters to cancel out, and I want to bring in the meters. A meter is a bigger unit than a centimeter, and I can also come over and find where that connection is, and I put 1 with the meter in the numerator and 100 with the centimeter in the denominator. Remove the common unit and then multiply across the top, multiply across the bottom, have your unit. So when you divide this out, that'll give you 4.32 meters. Okay, how about the next one? Here my units are a fraction. So when I have feet per minute, and it's 95 times that, it's 95 over 1, so that's 95 feet per every 1 minute. So that's just rewriting this in a form that gets ready to do the process. Now I want to change this to miles per hour. Remember, MPH means miles per hour. So actually I have a couple things I need to do here. I need to get the feet and change the units to miles, and I need to take the minutes and change the units to hours. So sometimes you need more than one factor within the unit conversion. You just pick which of the factors you're going to deal with first and then build upon that. So let's say we're just picking that we're going to go from feet to miles first. So I'm going to multiply it by my feet. I want to remove as common factors. So since the feet's in the numerator in the original, I need to put it in the denominator to get them to remove as a common factor pair. And feet, there's 5,280 feet in 1 mile. So I can change that right away to miles. I put the numerical values next to the units that they belong next to. And then that'll remove the common units of feet. Now I don't want minutes though, I want hours. So I'm going to multiply by another factor. The minutes are in the denominator right now. So to get to them as a common unit factor that will remove, I need to put the minute in the numerator. And I want to bring in the hours. And if you remember what the P in the miles per hour stands for, that's per every. So that's where your fraction bar is. So when they say miles per hour, they want the miles in the numerator, then the fraction bar, then the hours in the denominator. So it makes sense that the hours will be down here. Now, I don't have anything that relates minutes and hours over there, but we know from time that an hour is longer than a minute. I'm going to give that the 1. And then how many minutes make up an hour? 60 minutes make up an hour. And now my minutes will also remove. And then when you multiply across the top and multiply across the bottom, you have 95 times 60 over 5,280. And I have miles in the numerator and hours in the denominator. When we go through and we do this multiplication and then division, that's about 1.08. So miles per every 1 hour. So about 1.08 miles per hour. Okay, last one is, what about 10 feet per second? This one I actually came up with because my husband was watching a show and it said that this snake could strike at 10 feet per second for a particular snake that was being highlighted on the Nature Channel. And you think about that, I mean, 10 feet in a second, that's pretty fast. Well, what if we want to change that 10 feet per second to miles per hour? Because, of course, that's the first thing I thought when he was saying it struck at 10 feet per second. Okay, so we have 10 feet per second. We want to get rid of the feet and bring in the miles. 1 mile goes next to the mile in the numerator. 5,280 goes next to the feet in the denominator, and then the feet will remove. Now my time is currently in seconds, and since I want to go from seconds all the way to hours, and right off the top of my head I don't have like how many seconds are in an hour, or if I didn't, I would be able to then do it in 2 stages. So I'll go take out the seconds. So since seconds are in the denominator right now, we want to put them in the numerator to cancel as common factors. And I'll change the seconds to minutes. A minute is longer than a second, so I put 1 next to the minute, and there's 60 seconds in a minute. And then I'm going to multiply by the factor to get the minutes to go to the hours, because hours is where I want it to be at the end. So I'll put the minutes in the numerators to get them to cancel as common units. Hour in the denominator. An hour is longer than a minute, so I put the 1 by the hour. There are 60 minutes in an hour. The minutes then cancel. And when I multiply 10 times 60 times 60 in the numerator, so that's 36,000. So 60 times 60 is 3,600. And then when I take 3,600 times 10, I'll get 36,000. Divide by, in the denominator, I have 5,280. And that is miles per hour. And then when you go ahead and you divide that, you get that it's about 6.82 miles per hour. So these were just some different examples of how you can do the dimensional analysis method in order to change between units, whether you're just changing with the one type of a unit, or if you have a rate and you want to go from one measurement and rate to another. And hopefully you found those examples to be